All right, let's go ahead and get going. Looks like we've got a good group here today. Welcome everybody to another Prismatic Labs workshop. Today, I'm really stoked about this feature today. The large data sinks feature that we announced pretty recently. We're going to be diving into that in quite a bit of detail and nuance here today. It's something that's been requested forever, so I'm pretty excited about this one. My name's Taylor Reece. If I've not met you, I'm a developer experience engineer here at Prismatic. I want to kick things off with a poll. I'm curious for those of you who have had to deal with large data sinks in the past. I'm interested in how you're currently solving the problem. Like, did you build a workaround where you're doing some recursive flows, parallel flows, etc.? Did you have to increase memory and like tune concurrency and just kind of hope that things work out, or ask your customers to reduce the volume of data you're going to import? Or maybe you haven't even hit the problem yet. As you're filling in those answers, a couple of reminders. We will be recording this session, so if you need to dip out early or if you want to share it with a coworker later, we'll have that recording in our doc site in the next couple of days here. And then if you have any questions as we go, bottom of Zoom, there's a Q&A link. Feel free to ask some questions in the Q&A section there, and we'll have a dedicated Q&A time towards the end. Other announcement I want to make, fresh off the presses here, Prismatic Connect is coming up. This is a brand new virtual conference that we're going to be doing this year. It's going to be in September, mid-September on the 16th. Be about a 5 hour thing, and it's not just going to be me yammering about stuff. We've got a whole slew of great speakers and sessions for this virtual user conference. We will have a registration link coming out sometime in the near future, probably in the next couple of days here. But keep an eye open for that. It'll probably hit your inbox here in the next couple of days. But yeah, virtual user conference. I'm pretty excited because we've got a good set of speakers for this virtual user conference coming up. So with that, looks like there's some combination on the answers of everybody's done a little bit of everything handling large data sinks. Perfect. Perfect. So the problem with large data sinks here is it's pretty darn easy to create a demo and ship a demo, and it works great against some sandbox set of data that you've got. You've got a Salesforce, sandbox. It's got 500 records in it. You run your integration, it handles 500 records, perfect. And then your first customer, or second, third, whichever customer it is, comes to you with like three orders of magnitude more data than you've ever tested for. They've got 1 million records rather than 500, and you wind up hitting a couple of ceilings. For initial backfills, or if you're doing some bulk data refreshes, it might be the case that 1 million records just aren't going to process in the 15-minute time window that you have available to you. Um, and so you can do some workarounds. We've got things like recursive flows where maybe you page over a few pages of records, have a flow call itself over and over again until it's completed. We've got the idea of parallel flows where you're kind of going wide, and you take a bunch of your data and maybe split it up into chunks. So those 1 million records turn into 1,000 sets of 1,000, and you send it to some sibling flow. You might have some unique code steps or throw more memory at the problem, whatever. I see a couple of Elastic Path people on the call. I know you guys have had a really cool solution for this where you're effectively like calling a sibling flow with a custom action, but like awaiting like 5 promises at a time. So it was running, five executions at a time and pulling the results back. It was time to make this just a first class citizen on the platform. And so what we've built here is a way to do these big initial backfills or bulk data refreshes in a way that you don't need to worry about your 15-minute time window. And you can take large sets of data, the 1 million records or whatever, and split it up into something reasonable. Maybe it's 10,000 sets of 100 records or whatever. So we've got kind of native batching at the trigger level now. You can write a custom trigger in a code native integration, low code coming soon. But in a code native integration, you can create a trigger that will go fetch pages of data, and it kind of acts like a Python iterator. It's going to go fetch pages of data as they're needed. And then those sets of data are going to be broken into smaller batches and passed through executions in batches, where you can say, like, I want, of my million records, I want batches of 50, and I want to run three executions at a time. So at any point in time, I've got three executions, each processing a batch of 50. And over time, you're going to get through all of your data. Each of those batches has their own, 15-minute time window. And so even if it takes, you know, 8 hours or whatever to process all of the data that you've got, that's totally cool because you've got a bunch of individual executions that all manifest in the UI as a single execution where you can look at all of your batches as a single execution. On the other side of things, the other thing we've been working on is making things more observable. So we switched our backend that was holding step results and logs to OpenSearch, which is a purpose-built system directly for querying logs and whatnot. And so you should see a lot quicker and more dynamic, like execution, step result, and log uh, layers as well within the UI. So you can really drill into those batches of executions that run and like glean some data from it pretty readily and identify which ones failed and whatnot. So with all that yammering out of the way, let's look at some actual demos and start writing some code on batching things here. So for this first demo here, imagine that I've built a Salesforce integration and I'm particularly interested in leads. Maybe my app tracks leads in a bunch of different CRMs that my customers use. And I want to make it so that anytime a lead record in Salesforce is updated, my integration receives a request and gets the update. But in addition to that, I also want to make it so that when an instance is deployed for the first time, that I do a big like backfill of all of the records that already exist. In this example, I wanted to show some like field mapping and whatnot because every customer is different and every customer does some insane stuff with Salesforce. So imagine that my customers configured their integration to track Taylor wacky leads because they've got some custom record for type for some reason to track leads. And in their system, they've got 1,234 Taylor wacky leads stored up. Now, 1,000's not a big number in the programming world. But I'm using 1,000 just because it demos nicely, but the solution that I'm going to show here doesn't really care if I've got 1,000 or a million records. It's going to batch them all the same. And so the solution that I'm going to have here, which is going to take these 1,234 records from Salesforce, and it's going to dump them into some system that I control. In this case, it's a database with a table that's currently empty, but it's going to be filled up in just a moment. What my integration is going to do is it's going to take 1,234 records. It's going to fetch 200 at a time, and then it's going to process them in batches of 25 records at a time. So I'm going to go fetch 200, 200, 200, 200, pull them into batches of 25, process those each as, individual executions. I could futz with those numbers if I wanted to, but just imagine that maybe each of those leads takes a little bit of processing time. It takes, half a minute to process every lead. Maybe you're doing some additional like data enrichment on every single one, and you just know that about 25 is about what I can do in 15 minutes. You can do a little bit of voodoo and kind of metadata science on that. But if we do that data sync, just doing some quick math, that many records over that many batches 49 and a fraction. We'll do about 50 batches of records as we're importing this data. So if I go and kick off my batch processing here and I start looking in my database to see how many records I've got, none so far. Oh, there's my first 25 that came in. I've got 50 of them. I've got 100 of them. Looks like they're coming in. If I look at executions here, I can see that so far I've discovered 40 batches, 48 batches. So my trigger is kind of behaving like an iterator here. It's found 50 batches of records. I can see that all those batches are coming in 25 records at a time. And so far I've got, of my 50 batches of records, looks like I've got it set up so I'm running 3 batches at any given time. And then I've got a bunch of them that are queued up here at the end. Now, again, I'm doing a low number just for demo purposes of, on an order of 1,000 records. But if this thing needed to run for 5 hours to go fetch all of your data over the course of a longer period of time, then that's totally fine. You can just let it keep on chugging for a good while. Each of these individual batches has a good time window, the 15-minute time window where they can run. So if I look at my database now, I've got all 1,234 records pulled in from Salesforce. There's all my John Does and lorem ipsum sort of records that I've got. I should note here, you might notice that they didn't necessarily come in order. I've got my lead starting at number 25 up here, and then here's lead 0. And then I've got, lead 10 goes up to 24 and then 50, etc. The batching that I did configure was running 3 of them at a time. And if I kick off 3 executions at a time, they might not come exactly in order. You can, if you want to, set it up so only 1 execution occurs at a time, and it really operates as a first in, first out FIFO queue. But in the end, I got, all 1,000 some odd records. And if I ended up starting with 1,000,000 records, it would just take 1,000 times as long rather than taking 55 seconds for all of them to happen. It'd take, I don't know, mental math, a little under 1,000 minutes to crank through 1,000,000 records. All right. So I want to show off the source code for this integration, the Salesforce integration, in a moment. I don't want to get lost in all of the Salesforce and like Postgresisms of the code though. So I want to start by building like kind of a basic hello world code native flow that does the batching. So we can get a sense of the kind of structure of one of these batched large data syncs. And once we have our hello world one functioning, I'll pull up the corresponding like Salesforce data sync here. So for this hello world demonstration, suppose for a moment here, I'm going to use JSON placeholder as just a sample dummy API that I'm going to go fetch data from. If you've not played with JSON placeholder, it's just a little placeholder API generates some JSON responses. So it's holding, looks like it holds 100 posts right now. It's all just some lorem ipsum posts where every post has a user ID, an ID, and a title and a body, etc. JSON placeholder does allow you to do some pagination stuff. So I can say something like, if I want to start at 0, in other words, like start kind of acts as an offset in a database. So I'm going to start at record 0, but then I'm going to go up and fetch 20 records. So start at, well, really record, they call it ID 1. I've got ID 1 through 20 here. But if then I do an offset of 20, I'm going to get numbers 21 through 40, etc. So let's say I want to build a flow that is going to fetch 100 records total. Let's fetch them 20 at a time, and let's process them in batches of 5. So we wind up with like 20 batches of 5. So let's go ahead and build a flow that does exactly that. I'm going to start with a code native integration on my left side. For the purposes of demonstration, I'm going to leave my config pages completely blank because I'm not demoing config pages. And I've got a flow that is basically a no op. It's got an on execution function that just returns nothing. So for this code native integration, there's a couple of new properties that I need to set to make one of these batch triggers happen. First thing is trigger. And we've got this new helper function for a trigger that's called a batch flow trigger. I'm going to go ahead and import that from the Spectral custom connector and CNI SDK. And this batch flow trigger function takes as parameters a couple of additional functions, onTrigger and onDeploy. As the names kind of indicate here, onDeploy is going to run when I deploy my instance, so that might be my initial data sync. And the onTrigger function is going to operate as something that like whenever I get a webhook or a schedule, I can go ahead and like run that function. The reason I split these two things up is in some cases I might want my flow to be able to handle like two situations. And in my case here, I want my on execution function to be able to handle both an initial data sync of like, here's all the backfill records that I want to have in. Plus, I want my flow to be able to take like webhook requests thereafter and get informed of any updates that have occurred in this, fictitious third-party API. So I'm going to define a couple of functions. I'm getting a lot of red squiggles because I'm missing a property, batch config, that I'm going to set here now. Batch config takes a couple of values. Batch size is going to be the size of the number of records that should be processed by your on execution function at any given time. So I might go fetch 20 records at a time, but I might say like of those 20 records that I'm fetching at a time, break them into groups of 5 and send them on through. So that's one property I give to batch config. The other property I give to batch config is concurrent batch limit. This is where if you want it to be a first in, first out flow, just set it to 1 and only one execution is going to run at a time. If you'd like a little bit of parallelization, you can monkey around with like, you might start running into some rate limits in some third-party apps, depending on how much you're, fanning out horizontally. So you might want to do a little bit of, experimental science and say like, hey, it looks like about, 3 concurrent executions keeps me under some rate limits. I'll go ahead and just set that to 3 for now. So I've got the skeleton of what I need. Couple more things that I need though. I mentioned that I want both my onTrigger function and my onDeploy function, the results of these things to feed into my onExecution function. I want that to happen, and in order for that to happen, they both need to return the same shape of data. And to make that happen in TypeScript, I want to have some like pretty strict types to say that both of those functions return the exact same shape of thing. In this case, I want to return an array of posts. To do that in TypeScript, I really like Zod. Zod, if you've not played with it, it's a nice tool that gives you both compile time TypeScript types as well as execution and runtime type checking of objects to ensure that objects have certain properties that follow thus and such rules, that things aren't null and maybe numbers are between a lower and upper limit, etc. So what I'm going to go ahead and do here is I'm going to import Z from Zod, and I'm going to go ahead and say a post in the Zod world is made up of a user ID that's a number, ID that's a number, title that's a string, body that's a string. User ID that's a number, ID that's a number, title that's a string, body that's a string. Looks good. Thank you, Copilot. What's cool about Zod is I can also define a type of a thing by using z.infer, and now I've all of a sudden got a type that's a post, and a post knows that it's got a number and a number and a string and a string. Awesome. The other thing that I'm going to need to keep track of as I'm iterating over all these posts is my offset value. And I can name my offset value whatever I want, but I need to define a shape of the cursor that I'm going to be tracking. It looks like for this API, my cursor is a number, it's an offset. And so I'm going to go ahead and say something like type post cursor is equal to start, which is a number, something like that. And so now if I pass those two things, the shape of the thing I'm going to return and the shape of the cursor that I'm going to use as generics to my batch flow trigger function, post and post cursor. What's nice about that now is my onDeploy function, if I run payload dot pagination state, it knows that my pagination state is of type post cursor or possibly undefined if it's the first time this trigger is executed. So I've just got some nice type safety. And then later on, when I return some items, it knows that the items that I'm going to return is an array of posts. And what I return has to be an array of posts. And if I don't return an array of posts, then I'm going to get some red squiggles saying I'm doing something wrong. All right. So now I want to go do pagination stuff. So to do that, I need to go see if I've got a current offset. I will have a current offset if it's like the second or third time this iterator's been invoked. But if it's the first time it's been run, I won't yet. So I might say something like my start ID is equal to payload dot pagination state. That might be set. Or if it's not set, let's go ahead and just say it's my offset's going to be 0. Next thing, I'm going to go ahead and import Axios because I like the Axios HTTP library personally. And I'm going to say something like my response is equal to await axios.get. And I'm going to go ahead and get this endpoint right here. And I'm going to pass a couple of search parameters, including start. That's our start ID. And a limit. Let's go ahead and fetch them 20 at a time. Now, my response.data is not currently typed. So I can either explicitly say, I know that this API is going to return some posts, or if I want to, I can do a rather than a compile time typing here, I can do a execution or like runtime typing. So I can say something like post is equal to post. Let's turn this into an array here for a moment. I've got something called post array. I'm going to use Zod to parse my data that I got back so that it knows that posts now is either an array of posts or it's going to throw an exception and stop. And I like my code to, fail early if there's a mistake. So I've got some posts. Cool. Last couple things I need to do then. I need to return some stuff. Let's return the post that I got. And chances are I've not fetched all the data yet. I've not fetched, I've gotten up to post 40, but if I go ahead and fetch more posts, if I go and fetch 60 through 80, etc., if I can get 80 through 100, I've still got more. If I fetch 100 or any more than that, I'm going to get just an empty array. And so I need to return some information about like my offset that should happen next. Or if there's no more records to fetch, I need to return nothing for a paginated state. And when I return like a null for a pagination state, that indicates to Prismatic, this iterator is done fetching data from my third-party app. Don't keep invoking my iterator over and over again. So I'm going to say pagination state is going to be depending on if the number of posts is greater than 0 or not. I'm going to return, it's got to have the same shape as the cursor that I've got up here where it's got a dot start property. However many posts you fetched, go ahead and jack up the offset by that number. Otherwise, go ahead and just return null. All right, so what's going to happen here is this function is going to run the first time. My offset's going to be 0. It's going to get down here. It's going to return the first 20 posts. And then it's going to return a pagination state of start 0 plus 20. And then it's going to take this pagination state, bloop, pop it up to onDeploy function again, invoke onDeploy again. And then that 20 is going to come down 40, 60, 80, 100. And then it's going to identify there are no posts left. Let's go ahead and return null and indicate that we're done. So that's my onDeploy trigger. It'll run when my instance is deployed. It'll do an initial data sync and it'll pull in all 100 of those posts. The other thing I want to do, remember, is I want to make sure that my my onDeploy and onTrigger both behave similarly and return similar things, even though onTrigger might be invoked via webhook request. And so for my onTrigger function, I'm just going to say something like, let's go ahead and get let's go ahead and say post.parse payload. Let's go ahead and get the data that I got out of the webhook request. Ensure that it's a post with Zod. And then I'm going to go ahead and return, or maybe let's return items. Now notice I returned an array of posts up here and I want to be consistent about that. Because I want my on execution function to always get the same shape of stuff out, regardless of if it's the first time like an onDeploy run or an onTrigger run. So I'm going to put my singleton post in square brackets just because I want the shape to be the same. It looks a little silly because I've got a singleton record in an array. It's an array of size 1, but that's fine. And then if I want to return pagination state, I can, but I'm not paging over anything. So I can just say null, or I can completely omit that from my return value. But I've got my try. Maybe I'll catch an error and throw new error back out. I failed to parse the post, something like that. So last thing I want to do here is do something with my either onDeploy function that's going to be fetching 20 posts at a time and batching them up into groups of 5, or this onTrigger that just returns a singleton or a post. So I want to just guarantee, let's say const post is equal to post array.parse. By this point, we should pretty well guarantee pretty well have a guarantee that it's definitely a post array that we got back, but let's just double check here and, verify that we've got a actual post array. But then I might do something like, let's just do something hokey like log each one out. So I'll say something like for const post of posts, processing post with ID, blah, blah, blah. And maybe I'll print the title out as well. And then from here, I could, write something, write something about, pulling data into my own system. So the shape of what we've got here, just kind of reviewing, is we've got a trigger, a batch flow trigger. It's got something that runs when an instance is deployed, something that runs when it receives a webhook. Regardless of which path it follows, an on execution function is going to take those records and do something with them. Let's go ahead and build and import this thing for a moment here. And we'll even deploy to a customer to show that on deploy functionality. So we'll publish instances, deploy an instance to one of our customers. I can test those functions locally within the test runner if I want, but figure I might as well just show it running. Should see an on instance or on deploy execution run in just a moment here. There it goes. And I got some batches. Those aren't all the batches yet. Let's refresh just another moment. Almost all the batches, 19 of them. There they go, 20 of them, and we are done. So if we look at what we got there then, remember we were fetching 100 records. We fetched 20 at a time, and then the batch processor batched them into sets of 5. We've got a whole bunch of sets of 5, and if we look at the first execution, here's the post with ID 1, 2, 3, 4, 5. Next one has 6, 7, 8, 9, 10, 11 through 15, etc. We've got all of our posts shown here. And then I can also pass some data into this thing. So if I go ahead and let's say invoke my flow via webhook request rather than on instance deploy, and I take one of these shapes of one of these posts. We'll call this post number 101 here. And we'll say, this is the hello world post that I'm sending on up. Post request. There we go. There we go. An execution happened. In theory, an execution happened over here. Let's look. There it is. So I've got a webhook invocation rather than an on-instance deploy invocation. Webhook invocation. Because this is a batch trigger, it batched all one record into groups of 5. So I've got, just a single record. But I can see that I've got in my step outputs, I've got my one record, my hello world record, and I can see the logs. I've got, a hello world record that came back. I should show that if you choose any of these batch executions, you can do all the normal stuff that you do with executions, like see logs and see step outputs as well. So you can see what was actually passed to your onTrigger function. I can see that this onTrigger function for this specific batch got post IDs number 51 to 55. So that'll be kind of handy for debugging purposes. How long will it take batch logs to appear to your streamed logs? Great question, Marcus. Should be pretty instantaneous. I guess I've not played around with log streaming in a little while, but it shouldn't be any different than normal logging from what I understand on the back end. So that's like the shell of a batch flow that you might run. Switching back over to the Salesforce example, because I want to show off that like this is the format of like what a large data sync flow will look like in Code Native. Let's pull open the Salesforce integration for a moment here. I just didn't want to get lost in like the Salesforce and Postgresisms earlier. But what I have here is another flow. It's got the same stuff going on. I've got a batch config that's saying, run them 50 at a time, run them, or 50 in batch size, limit 3. When an instance is deployed, pagination in different APIs is different. Like obviously JSON placeholder used offsets. For Salesforce, I'm doing some stuff with the Salesforce query language, SOQL. So I'm doing something where I've got a little like where clause where I'm saying if there was an ID that I most recently fetched, give me all the records where the ID is bigger than the last one that I most recently fetched. Um, and then I'm doing some little bit of advanced stuff to say like, hey, if this is the first time running, if I didn't get a start ID, if it's the first time running, just make sure that we've got a Postgres table on my backend that's ready to accept some of those imported leads. I'm doing a little bit of field mapping here so that if one of my customers for whatever reason has something called a Taylor wacky lead that is a custom record type where uh, that maps to leads, I can do some field mapping here. But the structure is going to be pretty darn similar. We're in the end going to yield an array of stuff. In this example, yield an array of kind of normalized lead records that each have a name and an email and a phone number and the record type that it was imported from. And then on my onTrigger function, similarly, I'm going to receive webhook requests. This is where Salesforce is just an absolutely insanely large ecosystem in and of itself, where it'll send you big XML payloads, and then you got to parse the XML envelope and blah blah blah, do a bunch of silliness here. But our onTrigger function is also going to return an array of standardized lead objects. I should note here that that I can also return a whatever sort of HTTP response I want. So just like standard triggers, Salesforce happens to require for their webhook requests that you return an XML formatted acknowledgement payload back to them, or it'll just keep retrying the request over and over. So you can define the response that you're going to send back over to Salesforce when it sends some stuff. In addition to all that, I didn't show this off in the kind of contrived JSON placeholder example, but chances are you're going to need to configure some webhooks when an instance is deployed so that your onTrigger functions work. And so you can still reach for the webhook lifecycle handlers that you've always could. And so I've got some logic in here. And by the way, this whole example, um, if you go to our GitHub integration templates repo, this example is the Salesforce initial data sync example. So if you want to follow along with this example that I've got under flows here, all this code on the right is the exact same thing I've got on the left here. But you can do standard webhook lifecycle handlers, and then your on execution function similarly can do whatever you want. In this case, I'm taking all of my leads that I know are an array of leads, and then I'm throwing them into a database using some Postgres library that I pulled off the shelf. So there is demos. Recapping, we're doing some batching. You can do initial data syncs. Your webhooks and your backfills can all go through one on execution pipeline. I should note here, I should absolutely note here, we showed initial data syncs. It might be the case that you want to do periodic data syncs instead, where like at midnight on Sunday every week, that's when you do your data sync. If you want to do that, an onDeploy function is not necessary. If I take my onDeploy function here and make that my onTrigger function instead, I can go ahead and define like a schedule for when this thing should run, and that'll make it so that this function runs on a schedule that I've defined, and that'll help if you want to do like a periodic data sync instead. So an onTrigger function can also return pagination state. I was just demoing the idea that your trigger could do both an onDeploy initial data sync and handle webhooks if you wanted to as well. Right now, this is all available to code native builders. Low code and embedded workflow builder stuff is on the way. Obviously, for embedded workflow users, a code native integration is just not useful at all, but we're updating our triggers right now, our low code triggers, so that you can do that initial data sync, which is going to be pretty darn cool. Yeah. Couple of resources. I think we're posting those in the webinar chat. Thank you, Amarit, for posting those. I want to know what you want to talk about next. We got a bunch of stuff down the pipeline. I know that for a lot of engineering teams, the feedback that we've heard recently is that code native is or low code is nice, but we just want to write code. So if you want help converting some low code integrations that you have and exist to code native, we could do a whole session on that if you'd like. I'd sure love to dive into the MCP flow server. So like if you've got integrations that already exist and you want to have something in your app, maybe it's a chat bot or whatever, hook into your integrations to go fetch data from the third parties that your customers use. We could do a whole session on that. Third one here, I am really stoked on this one. We open sourced our components recently. If you didn't see that announcement in GitHub, Prismatic IO/components, all of our components are there. And so if you want to just fork it, build your own component, extend it, whatever, you go wild. And they're all there for your reference as you need it. We've updated our AI skills so that it's now cognizant that this exists. So if you start prompting in a code native integration, like, hey, I really want to do something with Amazon DynamoDB, then it should be able to just look at the component and see how it's structured. Or if you're a newer customer or you were previously on another platform, let's say you were using, Workato, Cycler, Paragon, whatever, and you're migrating some of your integrations from another integration platform, we recently released a Claude skill that makes it a lot easier to migrate onto our platform. Or if you have something else, go and throw it in the Zoom chat. Q&A stuff here. I think Marcus answered your question about Streamlogs. Ted, if we are currently using crossflows using low code, would you recommend converting to code native using this new functionality? Great question for that. I assume your use case, Ted, is that you have one kind of parent flow that's fetching a lot of data and then like kind of shelling it out or like fanning out to a sibling flow. That works totally fine, especially with the first in first out and concurrency limits that we recently released for flows. With that said, though, the advantage of having it all in just a single or as a batch is that you do get that kind of single execution view. So rather than a parent flow and then 50 other executions to other sibling flows here, you're going to see them all kind of manifest as a single execution. So observability is a little helped by batching. And then second question, is this expected to perform better than existing solutions? I'd be interested to know the answer to that question as well. I would expect the strategy of like splitting out set of records into sibling flows would probably run about as fast as batching, though I think we have something special with the batch trigger. I think there's something special with the batch trigger. You know what? One advantage you do get is that batches start processing right away. Although with sibling flows, they process right away too. I guess I would imagine just off the cuff that it'd be about the same as far as performance, but I'd be interested. I'll talk to our engineering team. I'd be interested to know the answer to that one as well. Great questions there. Thank you guys. You all have a wonderful day and hope you stay cool. Take care.